My name is Isaac from the Innovation Consortium, and today in this episode I would like to share with you about a vernier height gauge. With me here right on my table, I'm having an instrument. Here, and this is what we call a vernier height gauge. To start with, I would like to define what it is and what we use it for. As you hear the name, it's a vernier height gauge, meaning it gauges. So we use it to gauge different heights of objects or workpieces we are working upon. And the other use, it can be used for marking steel dimensions on the workpieces we are working on. How do we use it to measure the height, or how do we use it to gauge the height or the measurements of the workpiece? Practically, to show you and to start with, a vernier height gauge moves hand in hand with a flat surface. So in order to use a height gauge, you will need, like it or not, you will need a flat surface for the base to sit on. This is the base of the vernier height gauge. So this vernier height gauge, it has to be sitting on a flat and smooth surface, because in the operation of the gauge, it moves, and in the moving, it has to be moving on a very smooth and flat surface. So take for instance, if I want to measure the thickness and the height of this plate, how will I use the vernier height gauge to get the dimensions of this plate? First of all, this jaw of the gauge moves up and down in order to achieve, or in order to get the reading of the specific dimension of this plate. So if I want to know the thickness, I'll make this plate sit on our flat surface. We have a wood here, but in most cases we use a granite block, because for it it's very smooth and flat. With me here, I'm having this plate. So once we want to know the dimensions of this plate, we shall still use the vernier height gauge. It can give us the height, the thickness, maybe the width also. But this is a square plate, so it can give us the height and the thickness. The vernier height gauge, it has a moving jaw, the one you see here. It moves up and down. You just use your hand to move it up and down. But in the due course of moving, in the movement up and down, you're taking measurements on this scale, on the vernier scale of the gauge. So whenever it moves up, it's giving a certain measurement from the base of this surface we are having here to the tip of the jaw. So when it's down to the 0 mark, the jaw is on the base of the surface, and the 0 mark on the vernier scale is aligning with the 0 mark on the main scale of the gauge, meaning whenever the jaw is down on our base, the vernier height gauge will be reading 0. So whenever I move it up, any slight movement, it's the measurement. So the measurement now between the surface to the jaw will be moved on the main scale, and the accuracy will be given on the vernier scale. So meaning here, I've moved my vernier height gauge to a distance of 9.8 millimeters. So all measurements we are having here on the vernier height gauge, they're in millimeters, and it's the basic measurement we use in the engineering field. Now, as I had said earlier, we want to know the dimensions of this plate. Take for instance the thickness. I'll make sure the plate is lying on my flat surface, and I'll be moving the jaw to sit on top of the plate. So once it sits on top of the plate, that means I'll be getting the thickness of this very plate. So the reading I'm having here, it's 9.8 millimeters, meaning the thickness of this plate I'm having, it's 9.8 millimeters. If I want to measure the height, still the same process. I'll be moving the jaw upwards so that it reaches this height. As you move it upwards, you bring still the jaw, you make it lie or sit on top of the plate. So meaning you're getting measurements from the base of the plate to the top of the plate, and the dimensions you're having on the scale will be the measurements of the height of the plate. So basically that's how we use a vernier height gauge to gauge the thickness and the height of any workpiece we have in the workshop. We can change to a different workpiece. Take for instance these nuts. If I want to know the dimensions across flats of this nut and this one is big in size and the other is smaller, so meaning the dimensions will be different, or the measurements will be different. I still take the gauge, I just make it sit on top of this flat. Remember the other flat is sitting on our flat surface, meaning the measurement I'm having here, it's 46. So the distance between these two flats will be 46 millimeters. So always our datum or our reference where we get the measurements is the flat surface. So you should take note always when you're using the vernier height gauge, the surface should be flat, so as you achieve an accurate reading. If we go to the smaller nut, we lower down the gauge. Once it sits, the dimension I'm having here will be the size or the dimension across flats of that nut. So this one is reading 36, meaning across flats of this nut it's 36 millimeters. So once I place the jaw on top of this shaft, it will be able to give me the diameter of this shaft. I just make it sit on top of the shaft, so it's showing me 30 millimeters, so meaning the diameter of the shaft is 30 millimeters. So basically that's how a vernier height gauge works. So the other function of our vernier height gauge, as we have talked about, was marking out. So take for instance, I'm having this nut here, I measure it, the thickness it's 23.8. so if I want to mark off maybe let's say 10 millimeters, I'll go to my vernier height gauge, to this scale, I put on 10 millimeters, then I lock it with the locking screw. Then after locking, that means the distance from the base to the scriber, this is the scribe over here, will be 10 millimeters. Once I mark or scribe, I'll be scribing 10 millimeters on this nut all around. So that's how accurate the vernier height gauge is. You just make sure your workpiece is sitting flat on the base and the vernier height gauge is sitting flat on the base, and you do the marking out. You can see the measurements, the scribings where I started from, it's where the scriber is still going. So even if I rotate the other way around, the scriber will go in the same position. So that's how accurate it is. So it's having the base as its datum, or the starting point of the measurements I'm taking. So basically that's how the gauge works, the vernier height gauge. Actually, to talk about the different parts, or the most crucial parts of the vernier height gauge, the vernier height gauge has the base. This is the base over here, and it's the one which slides on the flat surface. It's properly ground at the base, and it's made out of a hard material so that it doesn't wear, and it slides smoothly on the flat surface, as you can see. We have the scriber. This tip here you're seeing here, it scribes, or it marks on different workpieces, as you had seen earlier on the nut. It's made out of high carbon steel, or at times high speed steel, or at times even they are made out of tungsten carbide, so that they don't wear. They are able to scribe a workpiece without even wearing, and for a longer time. It has a vernier scale. This main scale, actually, it has a main scale. This main scale gives us the rough readings of any workpiece, and it has the vernier scale. This scale you're seeing over here, it's the vernier scale. This one gives us the precise readings of any workpiece. So it could be 30 millimeters, 0.5. So the vernier scale helps us to get that 0.5 on any given workpiece. It has also the locking screws. So once I want to mark out maybe 30 millimeters, I'll move to 30. Thereafter, I'll have to lock so that the jaw doesn't move to any direction anymore. It can't go up, it can't go down, so it's locked in 30 millimeters. So you can take your scribing or marking without any movements. So basically that's it for the vernier height gauge. I remain Isaac from the Innovation Consortium. Thanks for watching. Wait for next episodes of how to. Thank you.